We've been asked to find the center, vertices, foci, and then to graph this ellipse. So I have x minus 1 all squared over 36 plus y plus 4 all squared over 49 equal to 1. And so right away, I see that my center is at 1 comma minus 4. Right, thinking about the same kind of shifts we would think about with circles in the center of a circle, or just like moving the vertex of a parabola when we were doing that. Next up, I need to find values of A, B, and C. All right, well, the values of A are going to help me find my vertices. The values of C are going to help me find my foci. And then when I go to graph it, B is actually going to help me find the endpoints of the minor axis. We're dealing with an ellipse, and so I know A is always the larger of my two values. So A squared is 49, and A is 7. B squared is 36, and B is 6. And then I know that C squared is A squared minus B squared. So 49 minus 36 is 13, making C the square root of 13. When I go to graph my ellipse, I'm going to need to know a decimal approximation for the square root of 13. And I know that that is about 3.6. Well, now I know it's about 3.6. All right, so I'm going to go on and start my sketch. I know the instructions say to find all of the things and then graph it, but I always like to get my picture going early. All right, so a bunch of tick marks here. My center is at 1 minus 4. All right, and now looking under the y term where I see that 49, that's telling me the value of A. I need to go up and down 7 to find where the vertices are. All right, so I can go on and think about where that vertice is. All right, so the x-coordinate is definitely at 1, and then I went 7 units up from here. Well, that y value is at minus 4, and when I add 7 to it, I get 3. So there's one of my vertices. Now I need to imagine going down 7. All right, and I actually should plot the point. I started at minus 4 and went down 7, so putting me at minus 11. My foci are about 3.6 units away from the center. And then below, 1, 2, 3, and about 0.6. So my foci, here in red, well, their x-coordinates are also both 1. And I had to start at minus 4, and to get to this one, I added root 13. And to get to the next one, I took away root 13. And I'm going to just write those exactly. Or if I wanted a decimal approximation, I could certainly find one, but I actually prefer exact things anyway, so I'm just going to leave those written just like that. Now, I'll find the endpoints of the minor axis. Now I can sketch my ellipse, or something I'm going to pretend is elliptical. Let's see, 1, 2, 3, 4, 5, 6, not quite to scale. Let's try that again. 1, 2, 3, 4, 5, 6. So this ellipse should actually be pretty round. It looks like my scale has this like looking further away, but we'll just let that be some error there in the diagram. So let's see, I found the center, the vertices, the foci, I've sketched it. I've done all the things I was asked to do. But every once in a while, someone might ask you to calculate the eccentricity of an ellipse, which is always the value of C divided by the value of A. So for us, it is the root of 13 over 7, which is about 0.5151. And what we can remember from class is that eccentricities that are smaller, knowing the eccentricity is always between 0 and 1, are rounder, and eccentricities closer to 1 are very stretched. All right, well, here is an ellipse with a vertical major axis, and that's it for now.